Why did you become interested in brain and what's going on?
Well, because I had worked in this, psychiatric hospital, eesti keeles?
Psychoneurolooghaigla.
Yeah.
Vaimuhaigla.
Vaimuhaigla, yeah. Psychiatric disorders are problems of emotion. And when I worked in the hospital as an undergraduate student, I became very interested in the nature of the problems. And I realized that we cannot have a science of this unless we understand the actual neurological mechanisms of emotion. And I was sufficiently evolutionary already that I recognized that you can understand emotions in any mammal, especially the little ones we have in the laboratory like rats and other animals. And if we work out the mechanisms of emotions in animals, we will understand human emotions. So that is the reason I shifted from clinical psychology into neuroscience research.
But how has the science changed since that time? When you started and now, how much more we know now about brain and about emotions and all those connections?
We know enormous amount more because when I started, the neuroscience revolution had not started. For instance, in America, the largest society for science in the world is the Society for Neuroscience. Neuroscience has become the largest science in the world because we're all interested in who we are. And when I was still a student, there was no society like that. Neuroscience was not represented in psychology departments, but they needed one person that knew about the brain in order to be accredited. So when I started looking for jobs, you know, they always needed one person of my type. And, you know, I interviewed at various universities, but I finally selected Bowling Green State University because they had this brand new building. We had probably the best research space in America, you know, so.
Right here?
Right here, yeah. Because, you know, they had built this 5-story building and the whole 5th story, as you saw, is devoted to animal research. And we only had 4 or 5 people up there. I was the brain person. There was one hormone person, and the rest were behavioral people that were running rats and mazes, behaviorists, which was the dominant force in psychology. And the behaviorists never wanted to study the black box.
But you said there was a neuroscience revolution. What was that?
Well, the neuroscience revolution was really, you know, starting in the 1970s. That so many people finally realized that we had the techniques to begin to truly understand the brain. And there were enough young people, older people that had worked a little bit on the brain. And, you know, universities started to develop neuroscience programs at that point. So neuroscience very rapidly expanded into one of the most powerful, largest sciences in the world.
And you were in the middle of that?
I was in the middle of that, at the very beginning of that. And the one thing they decided that was too complex to study were things like emotions. So a lot of people worked on learning and memory. That was the main question. Of course, that's very important. You know, we learn all the details of our lives. So enormous progress has been made on learning and memory. But I wanted to look at the ancestral memories, the memories that are built into our brains. I call them tools for living. And the emotions, I realized, had to be built in. Now, some people still think that you learn to be emotional, but no, we're born emotional. You just look at a little baby, you look at other animals, we all get angry, we all get scared, we all get sexually excited, we all get very curious about the world. We call that the seeking system. And, you know, there's happiness and sadness in the world, and we do not learn to be happy and sadness. This is a possibility of the brain. So I realized that this was a workable topic. It wasn't the most complex topic, but you would never understand it without brain research. So that's one reason I went to neuroscience.
And you started to experiment then on the rats and
Absolutely.
to find out those things. You also have been involved in the movement called affective neuroscience, or you've been talking about it. What is affective neuroscience?
Well, I coined the word
Right.
affective neuroscience, and I wrote the first book in affective neuroscience. Affective neuroscience is the psychological side of emotions and other powerful feelings like bodily feelings like hunger and thirst, and also sensory feelings like good taste, bad taste, pain on the body surface. But then there's the emotions, and the emotions are built into the brain. And people said that you can never go to the psychological part of emotion, which are feeling good and bad in various ways. And the first experiment I did there at the Veterans Administration Hospital was self-stimulation. So when Arnie Trehub said, what would you like to do, Panksepp? I said, I would like to see this phenomena of self-stimulation, namely an animal pressing a lever to change electricity inside its brain over and over until it was so tired it just fell down and fell asleep. The first animal I did was a great success. I had to build my own equipment, learn how to do surgery, and I put the electrode into the right place, and I dropped the animal on the lever, and the animal goes, and it worked for electricity in the brain for hours. So, I was so enticed by this phenomena that was discovered or published in 1954. Jim Old, Peter Milner in McGill University, Canada. And they just called it the reward circuit, because it was rewarding. They didn't talk about the psychological aspect of the reward, how it felt good, because that was not permitted. But it was very clear to me that this was the technique that allowed one to enter the animal's mind emotionally, things that feel good and bad. So my whole strategy for affective neuroscience was that you can map these emotional systems. And some mapping had already been done on anger responses. Walter Hess in Switzerland, in Zurich. He received the Nobel Prize in 1949 for working out the autonomic nervous system in the brain. Autonomic nervous system controls our heart, our stomach, our viscera, where we do a lot of our living. And it turned out that all these emotions seem to be organized in the autonomic nervous system of the brain. But Walter Hess chose not to talk about the emotions of the animal. He thought that when he saw what appeared to be angry cats, he stimulates the brain, the cat is very nice and friendly, stimulates the brain, and the animal goes, "Argh!" and attacks. He called it sham rage, meaning he was just producing a behavior that had no psychological component. Later, when he was an old man and writing his autobiographical books, he said, I always thought the cat was angry, but I did not want to say so because the behaviorists in America would marginalize my work, because you were not supposed to talk about things you cannot see, and feelings are things you cannot see. But of course, if the animal doesn't like that feeling, it should turn off. So for my doctoral dissertation, I mapped the anger system in the rat for the first time. People had only looked at cats up until that point. Some work in monkeys, but I took the cat and I mapped the anger system. But besides just looking at the behavior, I also asked the question, do you like the feeling? And wherever in the brain I produced the anger behavior, the animal would turn it off. It did not like that feeling. So my assumption was the animal was feeling something like human anger. Now, humans have been stimulated there, and guess what? They report feelings of anger. So all of a sudden I realized that we could map many other systems that way. People already knew that you could also produce a scared animal that, kind of became frozen for a while, and then you increase the current, it runs away as if it's scared. So I studied that system also from the affective perspective. Do you like it or dislike it, or is it neutral? If it doesn't mean anything for an animal, it's just like a puppet on a string. But when you stimulated this part of the brain, the animal would turn it off too. So you had fear, you turn off, anger, you turn off, and then something called reward. It turns out this reward is not like anything that we experience in the world. This is something we experience inside. It is a feeling that we don't have good words for. Words might be like enthusiasm, interest, engagement, happiness, a certain form of happiness that the animal experiences internally, and that drives it into the world to look for good things. So we called it the seeking system, and I think that is a very good word for the fundamental nature, the primary process. And that's why I started capitalizing these words to indicate I'm talking about a brain system. And these brain systems we can understand as being emotional because the animal shows a clear emotional response that you can see visually. But you can also ask about the feeling part by do you turn it on or do you turn it off? And at this moment in history, we can defend 7 emotional systems.
Like you mentioned upstairs, right?
Exactly, and I'll just repeat them, and I have them in order because the seeking system is the most important one.
Seeking happiness, rewards, pleasure.
All the good things in the world.
So that's the most important.
That is the most important one, because you damage that, the animal is no longer capable of doing anything in the world.
So that's the biggest motivation.
It is the biggest motivation.
For us and for animals.
Exactly. To be in the world with enthusiasm, looking for things, doing things that support your survival. So we think that the feeling of being an organism, a primitive feeling of self actually comes from that system. And, it is a system without a good name until you give it some important name. The reward system, the brain has many reward systems. It's a shoddy word.
But seeking is
a clear, we're talking about a brain system. We also capitalize rage, because rage exists because you compete for resources. And sometimes you have to fight for your resources, including your safety. So we have an anger type system in the brain that Walter Hess mapped in cats. I mapped in rats. Then you have a fear system, because some animals would like to have you as food many millions of years ago. And so you have to have an automatic way to protect yourself. So this fear system has an anatomy, it has chemistries. So once you go into the brain, you can understand the details. So seeking, rage, fear, and then you've got reproduction, and we called it lust systems. There's a different type of lust system for males and females. And this is one reason males and females often don't understand each other.
What's the difference?
Well, the difference is that the female part, I think, is more receptive, whereas the male part is more expressive. And I think you can put the story together yourself. Now, the human condition and the animal condition is that we're born with both systems. So we're not born with a male system and a female system. The male system comes when you're still a fetus and your gonads secrete testosterone, and the testosterone tells the brain to be male. And if that doesn't occur at the right time, the male brain remains female. So that's why we have homosexuality, because we are bipotential. We're both male and female in the beginning at a brain level. Of course, genetically, your female XX chromosome or XY chromosome, and the Y chromosome controls testosterone secretion when you're still in the fetus. So that manufactures the male brain. So a lot of people don't understand that a male can be male on the outside, which is controlled by other genes, but be a female inside the brain. A female can be totally female on the outside, but maybe the mother was treated with steroids, and the brain can be masculinized. So a female-looking body can feel like a male. So this is why we have this confusion that America is still having great problems with. I think other civilized countries have accepted it. America is still doing the gender wars. Homosexuality is a sin in the mind of many Republicans.
So this is all connected to the lust function then?
This is the lust function.
So, okay, so we have now 5. So what?
Now we have 4. We have seeking, rage, fear, and lust.
Okay, 4.
Once you have babies, you have to have a brain system to take care of the babies. We call that the care system. And the care system is much stronger in females than males. And it comes online, becomes very active due to the hormones of pregnancy. The hormones of pregnancy bring this system to completion. So the mother, several days before the baby is born, they might be scared, can I take care of my first baby? But after the hormones go in, they develop a courage. I can do it, a kind of different attitude. So the care system is also a system of confidence. That is what a mother needs, confidence to take care of this new baby with love, devotion, a special relationship. A child that doesn't have that relationship will always have psychological problems later.
So that's 5.
That's 5, yes.
Then we have grief.
Then we have grief or panic, because a baby has to have a system to indicate how much it needs the mother and parents. It cannot survive without others. If you are lost and you don't have a way of signaling that you're lost, then you will not survive. So an animal and a human, a young human, to survive has to have a system that tells you how important others are, and we call this the panic system, and we measure it by young animals separated from mother for a short period, and they begin to cry, the separation call. So this is a system that we put on the neuroscience map completely ourselves. There was no science of this system, and we spent, 20 years of solid work on that system. We mapped the chemistries in the brain and the anatomies in the brain. We know where it is. And now that we have modern brain imaging, people that have looked at human sadness find that those areas of the brain are active during sadness. So we think that this panic system is the source of grief, of sadness, which I have had plenty of in my life. Most immigrants have.
Loneliness.
Yes, loneliness, and you lose everything. That is almost like losing your mother. So when my parents had to leave Estima, they were in strong emotional states of grief and, what will happen, anger and mixed emotions. So this is the emotion that connects us to others, because others give us the good feeling of companionship. So this system is so important in psychiatry because the source of depression is the psychological pain of losing the ones you love.
So this is the system we can use explaining depression.
This is one of the systems. Depression is very complex, but it looks like one of the major roads toward depression is this system being overactive for too long. And our neuroscience work suggests that when this system is overactive for too long, it tends to suppress the seeking system. So the seeking system, the desire to be in the world, is dampened, it's reduced. And we've got data for that. So you've got one more system after that, which is the most wonderful of the systems. We call it the play system, because young mammals have so much to learn about others. And if you don't have a system to learn about others automatically, then you will not be a sophisticated social creature. To be a mammal is to be social. And play takes young children to find other young children, and they spontaneously start to do interesting things with each other. They run around, they chase each other, they pretend that one is the lion and the other is the sheep, and they hide and seek. These are all the kinds of skills that you need at a fundamental level, but you also have to know what you can do to others and what others can do to you, what you shouldn't do. So play tends to take children to the point of bad things happening. So we started the science and the neuroscience of play. Prior to that, there was no systematic procedures, and a lot of people were kind of like, play, that is trivial, that's extra, that's not important. I think it is one of the most important emotional systems and the most recent system, one of the most sophisticated systems, and this is the system that we have been using to understand happiness.
So, in other words, affective neuroscience is comprised of those 7.
Right now,
so this
yes.
is when
these are the big ones.
So when we say that you coined the term and you mapped this,
yes.
So this is the map
This is the map.
you laid out.
This is the conceptual map. To understand the neuroscience map and neurochemical map, you have to read my 1998 book, Affective Neuroscience, or the one that just came out.
One of your biggest contributions to.
This is my big contribution.
Right.
This is my life work.
Right. Yeah. But let's talk now, in the end, about happiness and depression.
Mm-hmm.
Your last book is about what makes us happy. But what is happiness?
Yeah.
So what is happiness? Is this chemical reaction in the brain,
Yeah.
or using your map, is
Mm-hmm.
it the stimuli that we get from outside,
Yeah.
and that makes us happy? What makes us happy?
Well, our brain makes us happy, our mind makes us happy, and our mind is designed to be connected to the world. So we cognitively see the world as making us happy, but of course it's the things in the world that we need to survive that make us happy, but the signal of happiness is a within brain mechanism. And this is what's made it so difficult, because we cannot see easily into the brain. We also have a more difficult time seeing into the mind, namely experience. And what affective neuroscience opened the door to was to do this scientifically, as opposed to maybe humanities and arts, which live upon these things. So music without emotions is not music. If you go to the theater and the human passions are not expressed, you don't want to go there. So much of our life revolves around these deep internal feelings that are connected to the world. So of course, having a good world helps in being happy. No one would disagree with that. We've known that since we started to talk. Aristotle wrote about it more beautifully than anyone since then. He also talked about emotions and emotional wisdom. The emotions don't have wisdom. It's the cognitions that give us wisdom. But you can only have these cognitions if they've been properly controlled in learning and memory, with a good world, getting the best thing inside of you, and the two starting to do a dance. And if that dance is beautiful, then you have mental health. And if that dance is bad, it can be bad for genetic reasons, then you have a psychiatric disorder. So happiness, the goal of every life, to try to avoid too much sadness, too much grief. That is connecting the inherited potentials of all mammals. Not just human beings, but every mammal and maybe many other animals, to the kinds of worlds that support the brain systems. And we have not yet developed, I think, a full concept of how that happens. And one reason I wrote this recent book, which is Archaeology of Mind, trying to dig deep into the brain to understand our psychology in a deep sense. That vision has complete respect for all the humanities, from the great arts to politics and literature. And surprisingly, one of the first classes to use this book was at State University of New York at Binghamton, where I will be talking in a week. People in the English department invited me. It wasn't in the sciences, because they used my new book in an English course, in poetry. And the students were asked to use these basic emotion systems to not only interpret some poetry, but to write their own poetry. So some of this was their assignments, which of course makes me happy.
But when we try to explain or define what is happiness, what is the state of our being that is the happiness, when we are happy?
It's a world that gives us many opportunities to do many interesting things with many interesting people, with many interesting and wonderful meals to share, music to share, all the good things in life that we all understand.
That is happiness.
That is happiness, and that is the responsibility of culture as much as families, as much as yourself as an individual. That it's more important to be happy than to have lots of material things. And we have not developed those values sufficiently. We have not built governments that support that vision. We're still in some primitive phases in certain countries. We're having an election here in America with two very different visions. The Democratic vision, Obama, is a vision that we build cultures where we try to maximize happiness for the largest number of people.
And the other vision is more materialistic.
It's more materialistic, that I can collect as much as I can and others don't matter as much as I do. So having a vision of equality, which our Declaration of Independence was based on, these truths are self-evident, that all men are created equal. And, it basically says that the responsibility of government is to make sure that that liberty, which is fundamental, is supported by the social structures. And
but government can help to kind of guarantee the equality and promote happiness. But can scientists come in and help people to be happy?
Scientists can certainly make many young students happy. To get degrees and learn about the world. There's nothing more exciting than science, Science is the field that allows you to truly understand the world. All the things that we don't understand, we can always be making progress. That's a source of happiness. It's brought me great happiness. Enormous amounts of work. So happiness comes from the work you want to do.
But the science can... Is it possible to have a happiness pill or gene?
Happiness pill. I don't think a happiness pill will ever exist. I think we can support brain chemistries that have become imbalanced, brain systems that have become imbalanced. If the world has had too much pain for you as an individual, if you've had certain genetic patterns that do not support happiness, we have personalities that are biological. We have genes that control sadness. You can have too many genes that make you anxious. You can also have genes that tend to give you chemistries that make it easy for you to be happy. The classic temperament was sanguine. You're just a happy person. You had other personality types that were phlegmatic, cold. A cold person that didn't seem to have the things to make them feel warm toward others. There was choleric, angry people. And then there were super sad, melancholic people. So these were the four classic temperaments. Neuroscience supports that old vision very well. Now we have lots of, fancy personality tests that often don't tell us as much. The world and the body go together. If we send ourselves in capsules to live on the moon, we will not be happy for too long.
We can conclude that we have responsibility ourselves almost
Yes.
to make ourselves happy. We
Yes.
can't go for substitutes or pills or whatever to the science that
Yes.
something makes us
Oh.
happy.
I mean, pills and chemistries can always help. Now we're in the era of cosmetic pharmacology. We have pills to allow us to stay awake more, to go to sleep more. These are all psychological pills. But, I think like everyone realizes, it's your individual responsibility to be a person in the world and to search for things that will make your life satisfactory and happy. Many people that go for money and material things find at the end of that journey is unhappiness. It's a lack of completion. So, people that take all the values, good values of life, and try to be part of them and to touch them, to support them, I think they are cultivating a field that's a very broad field, and happiness is the final word. In other words, we don't have a happiness system in the brain. We've got a system that can make us feel good in various ways. Seeking, lust at certain moments, care, which is a source of empathy. You want to take care of other people. We also want to have a good time, play.
Social connections.
Like social connections. Play is the source of friendships.
But you also brought a great example about drugs and alcohol that might make us happy for a certain period of time.
Sure, yeah.
So tell this again, that how the brain is going back then to the other side.
We have chemistries for feeling good in various ways. So we've got reward systems. Not just one reward system, many. The taste on the tongue of a wonderful food is a rewarding experience. If you're cold and you can go into a warm room, it's wonderful. It's another rewarding experience. We have many of these rewards, but the system of enthusiasm, the seeking system, that if you have it at a high level, but not too high, you are an interesting, enthusiastic person that other people want to be with. But it can be also excessive. There's a psychiatric disorder, it's called mania. People are just unrealistically happy. Now, if you can stay in that state, you might feel good for a good long time, but you will have problems because you will begin not to be able to relate to people very well. So the problem with mania is it makes you so optimistic at times that you do stupid things. Namely, you take your little pile of money and you invest it in Wall Street, and they decide to take your money away, which happened when Obama became president,
But what happens with drugs and alcohol?
Well, drugs, all the drugs that we like, and there are three main categories. There are the opioids, the most ancient ones. And the opium poppy has the substance we can make morphine from. This is a wonderful feeling of warmth and satisfaction. And of course, a person that is lonely and in pain wants that kind of feeling. And this is the system that produces that feeling. So it can be very addictive. The problem is when you take too much of those drugs, the negative part of the system grows stronger, and then you don't have the drug, and you've got psychological pain, and that psychological pain is like loneliness. It's like having no social support. It's like a child that's lost in the woods without parents. And that's one reason people get addicted to opioids so easily, because many people are lonely, they're in psychological pain, and they find this molecule can take that feeling away.
Alcohol, the same thing.
Well, alcohol is a very different feeling. Opioids generate social bonds inside the brain. Alcohol has been around forever. Alcohol is a messy drug. Alcohol can tickle your seeking system, so for a while you're kind of joyous and happy and party. Of course, then it suppresses parts of your brain, too much GABA activity, until you become unconscious. You know, some of our anesthetics in the hospitals are GABA facilitators. Prior to our new medicines, when you had to get a tooth out, you were given a bottle of whiskey. And that facilitated GABA and the pain wasn't as bad. But it's a really dirty drug, so it has many effects, many molecules. A clean drug, that's an ancient one also, is the one that cocaine comes from. Remember, cocaine came from the coca leaf, which was in South America as part of the culture. People had to chew coca leaves, and they had to take an alkaline salt to pull out the alkaloids from the coca leaf. So they had a tradition, and they felt energized, but it was a very natural, low-level energy. And then people discovered the molecule, and they manufactured it, and they found that it was good for certain medical things, like putting in the eye for eye surgery. And the first one to study them was actually, one of the first people was Sigmund Freud. Sigmund Freud wrote a whole book on coca, and he became a cocaine addict himself.
So that creates you this energy, and then you have the drugs that really,
absolutely,
like the marijuana.
Yeah, marijuana is another interesting one, but let me just say an aside, the era of scientific pharmacology, psychopharmacology, goes back to University of Tartu. The discipline started there, and two people were very influential. One was in pharmacology, Rudolf Buchheim, and the other was Emil Kraepelin, the one that started the science of psychiatry.
When was that?
Kraepelin was there at the latter part of the 19th century. So, you know, my friends ask me, where were you born? And I kind of, with a little humor, say I was born in Kraepelin's laboratory because I was born in the woman's clinic, Tartu Ülikoolil. You know, Kraepelin's lab was just very close to there.
So they started these studies of those.
They started, yeah. The
effects
science,
of
exactly. So Kraepelin did some work on opioids and on cocaine.
So he's really a pioneer on that field in the world.
Absolutely.
So you said there are three groups of drugs: opioids, then the cocaine. So what's the third one?
Well, the third one are the cannabinoids, as you mentioned. Yes.
So kind of.
The cannabinoids, of course, have been around forever because they're part of a chemistry of a plant, and that plant was found to contain tetrahydrocannabinoids, which activate the brain in the marijuana smoking, and then they found that these molecules were also inside the brain, and the first one discovered was anandamide. This was your internal cannabinoid.
But these are all temporary fixes.
Of course, absolutely.
So we can't,
but see, every one of these operates through a brain system that we inherit. No molecule would be attractive if it could not use the systems in the brain. So the opioid system is incredibly rewarding. It's very much a social kind of molecule. Makes you feel good and secure, like mother does. Cocaine is the seeking molecule. It pushes you into the world with energy, enthusiasm, and that's what the amphetamines and cocaine do. And then there's this mysterious cannabinoid, marijuana, and
then there is a backlash.
Yeah, there's always a backlash. Culture doesn't know how to live with these molecules.
And your brain also, you said.
But the brain has learned to live with them because, the many of the moods and emotions ride upon these chemical systems.
Yeah, but when you withdraw those
Yeah.
stimuli, what happens then in the brain? You said, then you still go back to these feelings of loneliness and
You'll feel
emptiness.
terrible without those systems. Feel terrible.
So this is called addiction.
This is, then you have this addictive urge. Now you want to fulfill those chemistries with external molecules. If you have taken these positive molecules away in whatever way, life can produce it, drugs can produce it, you will have feelings that are psychiatrically important. So depression is the lack of good feelings, the lack of capacity to feel good.
So in other words, when you stop, you take drugs, you
Right.
feel happy.
Yep.
You drink alcohol, you feel happy.
Yep.
So what happens when you stop?
Well, you feel bad. And then you want to take more of those molecules, and that's addiction. And all addictions share some things, but they also have something unique. So we have not learned how to train or treat addictions, and we're still in the process, and people are looking for chemistries against addiction. Initially, they thought that cocaine would be a treatment for morphine addiction. And guess what? Freud treated one of his friends that was an opiate addict with cocaine, and he became a cocaine addict.
So we have all kind of support systems and things, but you said we haven't found the
We haven't
ultimate treatment.
We have not found ways to balance the system, and we have not found any mind medicines, psychiatric medicines, where the concept has come from human knowledge as opposed to just chance. Remember, all these molecules, alcohol, marijuana, opioids, cocaine, they were discovered by chance in plants. So now, in the modern neuroscience era, we know what receptors and what chemical systems they're acting upon. But the interesting thing is that many psychiatric disorders come from imbalances of these systems. But we're not going to treat depression with cocaine. Before the modern era of treatment of psychiatric disorders, the best antidepressant was morphine. It worked very well. But the benefits were short-lasting. The person would get addicted. But we already have safe molecules that are not addicting, that could be used to treat depression, but are not being used because they've been demonized. You know, why we demonize molecules as opposed to understand them. You know, America has this sickness where it takes addicts and puts them in jail, as opposed to sending them to really good treatment facilities. I think a civilized society that truly understands what addictions are treats the people differently.
But is it possible to treat them?
Yes, yes it is. The best treatment is, in America, for alcohol is Alcoholics Anonymous.
But it's behavior modifying.
It is using other people and social relationships to support the brain systems that you've been treating with chemistries. So the reason Alcoholic Anonymous works is because it's designed to have addicts that make certain commitments to each other to be open and honest who they are, what they've gone through, and where they want to be. And you know, there are not too many places in the world where you have other people with similar problems, where the whole thing has been structured to be honest about life.
So it's a social setting again.
It is a social therapy that is, the people with the problems treat each other by being full human beings.
So no chemicals, no pills.
No, that's one of the rules. You will not be part of us if you take any of those. And if you have a need to take any drug, you have an older person that's gone through the journey, that your responsibility is to call that person immediately.
Right. But has the science discovered any drugs to treat those addictions? You said no.
Well, there have been possibilities that have been raised. Right now for cocaine addiction, the biggest treatment idea is that you produce an antibody in the body that if you take cocaine, it grabs it and takes it out. Okay? So there are ideas, but
still ideas.
Yeah. The chemical treatment for opiate addiction right now is this safe opiate, which is called buprenorphine. Buprenorphine acts just like morphine and heroin at tiny doses, but then the molecule in its complexity and many faces at a higher dose blocks the same receptor. Okay? So you can take a little bit of it, but you can't take large amounts. And this prevents the cascade of addiction. So it can become habit forming, but it can't be this super addictive where you go into cold turkey withdrawal. So it was accepted in France, 20 years ago. In all other civilized European countries, it was treatment 10 years ago. It took America much longer to allow that to be used. And America was so scared that it did not provide the clean molecule. It put another molecule in there.
So, but basically still this behavior modifying therapies are still the best tool.
Overall, yes. Just like in psychological problems, if you can alleviate the problems psychologically through human relationships, you're much better off. But there are now, more subtle chemical tools that people can use to solidify positive memories. So, if you go into psychotherapy and you talk about your problems, and you have to bring the problems into the open, but now people have discovered that every time you bring memories into the open, the memory goes back in a slightly different form. And this thing is called reconsolidation, that every memory is not like a mountain, the way we thought they were. They're within a dynamic interaction with the environment. So a therapist brings bad memories and talks about them. If you can change that bad feeling into a good feeling momentarily through human interaction, find something that you can both laugh about for a moment, that memory is not as painful when it goes back into the brain. So we have chemistries to facilitate that.
So basically what I wanted to, when I say in the program that there are ways to chemically treat those things, but still the behavior therapy is the strongest.
The psychological therapy, yes.
Yeah.
I wouldn't call it a behavior
therapy.
The
psychological therapy.
Psychological therapy, because one reason I left clinical psychology was because the main treatment was behavior modification.
Right,
behaviors,
exactly.
If it were psychological treatment, if it had been psychoanalysis, I might have stayed. So I was just fortunate.
But now there is this big field of happiness, like at the United Nations, we talked in New York.
Yes.
So what do you think of that? Like the countries have to include in their life quality index not only economic data, but also data about happiness.
I think that's a wonderful idea. To be a mammal is to be a social animal. That's fundamental. Alligators and snakes, they can be isolate, solitary animals except for sex, but to be a fully social animal, namely the concept of family is biological and the extended family is cultural. I think, part of government is to give as many people the possibility of feeling that they are in an extended family that, also takes its material dynamics, buying things and cost of things, and tries to make that part of a sense of equality. And, no one has solved that problem except maybe small countries like, was it Bhutan?
Bhutan, yes.
Bhutan, they've got the National Index of Happiness. I think it's really a valuable concept. And, I think this indicates the human imagination following our basic feelings and saying, even though these basic feelings are not smart in the intellectual way, because we have this big thinking brain, we can be smart, not just as individuals, having nice healthy families, we can have a larger groups, and the human family that, you know, shares some values. And, you know, these values have a connection to the material domain, and, you know, government has to support that. And the government has to support that in a way that more and more people have what they need of the material world to be psychologically happy. But those material things are not the source of psychological happiness. You know, the source is a sense of solidarity with others, you know, families, you know, people that feel like they're working together toward common life-affirming ends. You know, the biggest one, save the earth.
Right. And finally, the last topic we will touch upon is depression a little bit. So you said it's a very complex.
Yes. There are many kinds of depression. And we don't know how to cut the pie, the different kinds of depression.
But the main thing is feeling lonely, feeling
Yes,
hopeless.
that's the source. If you're in psychological pain, and, you know, this psychological pain that evolved from physical pain is when you don't have social support, you don't have love, you don't have that good feeling of friendship and solidarity. And, you know, that has neurochemistries. And if those neurochemistries go too low towards psychological pain, then eventually you can't get out of that hole by yourself too easily. And you can essentially use chemistries to support coming out of that hole, but
Pills.
it's a support. You know, it's not a cure. It is, you know, something that has to go with things in the real world as opposed to just the chemical world.
So what to do?
Well, you find the chemistries that make you have the capacity to feel good, but are not addictive. And, you know, that's one reason we have been studying the main source of psychological pain, which we call the panic system, and the main source of psychological joy, which is the play system. They're symbolized in the two masks of theater, the sad face and the happy face. So, you know, these two principles are connected to these two enormous and powerful psychological systems. We can now look for chemistries that can soften psychological pain, and we already have them. And
Antidepressants.
they are not the antidepressants that are being used, but there are molecules that are available that could be used. They're not being used because for some reason we're not taking the psychology of animals seriously and making the translation to humans. There are also molecules that can just make you feel better, more playful. Cocaine and amphetamine are not those molecules.
What about antidepressants that
Well,
are so widely used?
The antidepressants that we have right now, everyone was discovered by chance. It wasn't through human knowledge. A molecule had been developed for other reasons, and that other reason we saw that people were happier. So it was just used in depression, and all kinds of theories of depression were built upon the knowledge of how those molecules act in the brain, but they are not good medicines. They might be good medicines in the short term, but the problem with every antidepressant is that it might be good in the short term, but it builds up the background opposite process. So the thing that you were escaping from is getting stronger in your system. So when you take the medication away, you're worse than you were before.
So you still need those psychological therapies. What
You need psychological therapies, or you develop medicines that facilitate the positive without the background negative building up.
How far are we from those medicines?
Well, we're very far, but I think our group in Northwestern, you know, that developed the GLIX13 is as close as anyone. So,
What is the GLIX13?
The GLIX13 is the molecule that came from analyzing what play, happy play, does to the cortex of the rat brain. And, you know, we just used the vigor of modern technology to give us candidates that this might be a happier pathway, this might be a happier pathway if they had been turned on by play. And it turned out that play activated 1/3 of the genes in the cortex. And the cortex is not needed for play. So we're looking at the cognitive apparatus that play influences, but is not play itself. That's programmed by play. And, we just had candidates from the, hard technologies. And then we tested the molecules in our animal models, especially using the rat laughter as an index, that now you're feeling socially good. And this is the first psychological model of depression in animals. All the others were just behavioral models. So by taking the animal's psychology seriously, we can ask, does this molecule promote human social positive feelings?
So what, in the future, what can be the use of it?
It can be used to treat depression.
As a pill?
As a pill, yeah.
So we can take it and our body starts to
be more receptive to the social world.
But since you said it's so far away, so what's today?
Well, this is
the best medicine.
This is as close as anyone is to tomorrow.
Right. But how far is this tomorrow?
Well, for GLIX13, it took us overall 20 years of work. This work goes back to when I was still at Bowling Green before I joined my friends in Chicago. And but the hard work started in Chicago, but we had the concepts, and we eventually came to a molecule that looked like it was safe. It was a target in the brain that there were no medicines for. So, we studied it from all different directions, and everything looked good as far as the animals can tell us. It looked safe, and it had no poisonous effect on the body the way many of these psychiatric medicines do. And it turned out it elevated this social joy, and we got to a point where the Food and Drug Administration allowed the first human test. Now that test required so much money that you have to sell the idea. That's where the capitalism comes in.
So it's sold now?
Well, yeah, the idea is sold.
But when it could be on the market?
Well, it's all the next phase. In other words, in the American system, to get to that level, we needed $16 million for the first human trial. 4 groups put $4 million into the pot. They're called venture capitalists. They are going for things that are on the horizon, high risk. They take the risk, they support the study passed. Now they want to sell it to the next level, okay? That hasn't been achieved.
So it's still years away,
well,
might be.
Of course, yes.
But that will be the first and organic...
If it actually works, it will be the first psychiatric medicine, a new concept that's come from human knowledge. And we keep our fingers crossed, because now it is in the arena of society, business. It's, not within the science domain as much as it was. But that's the way every one of these medicines has to occur.
But before this drug comes, what is the best way to treat depression?
Right now, I would say that it's back to the first of the chemical antidepressants. Remember, morphine was the only way that really treated depression very well back before 1954, the birth of modern psychopharmacology. But it caused addiction. Then a molecule was discovered that stimulated only at low doses but blocked at high doses. The use of this molecule at tiny doses is one that we have been trying to test for 12 years. But we haven't succeeded because we haven't been able to get the permissions. But there's enough clinical data because doctors can use a medicine that's approved for something else, for something other. And enough doctors, enough psychiatrists have used this medicine for individuals where the other drugs didn't work, where they've had wonderful results.
So we can still use antidepressants.
We can use this molecule as an antidepressant if a doctor is willing to prescribe, but it can't be advertised as an antidepressant. We have a study going on in Israel where this molecule is being tested as an anti-suicide agent. When a person from depression usually is about to kill themselves, they don't have enough joy, enough good feelings to live, we thought that we might be able to restore these feelings sufficiently that the person stops thinking about killing themselves. That study will be finished at the end of this year. You know, we initially did 4 people, and 3 of the 4 showed pretty good psychological effects. That was an open trial. Should we go further? Now we've been in a double-blind trial for a couple of years. This is, you know, friendly psychiatrists in Israel. And so we'll know in a couple of months whether it worked in a larger study. If it worked, it'll be the first anti-suicide medication.
Right. So there are things in the works, as we hear.
There are, yeah.
But again, but in a very short one, there is a patient or viewer who is really severely depressed and wants to get this idea. What is the best medicine that is available now? Should they go to a group therapy?
I would say that's up to the doctor that's working with a patient. I don't think there's a general
answer. First thing, go to the doctor.
Yeah. There are the antidepressant medications that are used right now are very good in the short run. But you know, some of them take a long time to take effect, 3 weeks. But they can be used in the short term as anti-stress medications. And you know, in the long term, they're not as good as doctors thought.
But what's good in the long term?
Well, I would say that a person that hasn't gotten benefits from the traditional ones, the very tiny doses of buprenorphine are probably the very best thing that exists. Now, you know, a lot of people would not agree with me on this, but this is based upon these take psychological pain away, and the psychological pain is such a large source of depression. It does it rapidly. That's why it might be a good suicide, anti-suicide pill. And doctors all over the world can prescribe it, but at much lower doses than they're accustomed to.
Right.
Okay.
But what about this kind of group therapy settings? And
I think psychotherapy will always be there. It will always be there. Pills will not substitute for psychotherapy. The pills
for depression,
for everything. They have to go together because eventually psychiatric problems become problems in thinking. And pills do not correct problems in thinking. So what the psychotherapy can do is allow a good psychotherapist to bring the material and the memories out and to reframe them and to get a person thinking in a different way that then supports the medications. So that's always been the best, that you can use psychiatric medicines at low doses if done with psychotherapy. What happened in America and many other places in the world was just treating with molecules that were pretty good in the short term, and people didn't worry about the long-term problems. But it looks like these medicines have created more psychiatric problems than they solved. You know, we have more poorly treated schizophrenics, poorly treated depressed people that, you know, are getting some benefit from the medication, but they can't get off it because they will feel worse than they felt before. So.
And the final question of this big interview, are you a happy person yourself?
We could all be a little happier. Let's say I am happy enough. I've had a lot of pain in my life. You know, I lost a daughter when she was 16 years old. That is a painful event. I was a single parent at the time. those are the kinds of painful memories that one never disappear. So, you know, I am a person with enough pain and enough happiness to respect both sides of the spectrum.
Okay. Thank you very much.
Thank you.